Hey everyone, how are you all? I am Smita, your PM mate, and you are watching Top Physics News only on Physics Mind Bubbler. In this video, I am going to talk about Pristine quantum criticality, spin Seebeck device, and Milky Way. This video will give you great insight into the beauty of physics. So, let's get into the video. First, let's talk about pristine quantum criticality. In everyday life, phase transitions usually have to do with temperature changes. For example, when ice cube gets warmer, it melts. But there are different kinds of phase transition usually have to do with magnetic properties. In order to understand the quantum properties of the material, phase transitions are interesting if they occur at a zero point of temperature. And this is also called as the quantum phase transitions or quantum critical point. Now, the properties of these materials are now being further investigated, and it is suspected that the material could be so-called well-condensed semi-metal, and it has a great potential in quantum technology because of the presence of spatial quantum states, and this is also called as a topological states. In typical metal and semiconductors, interaction between the electrons are very big, and that is why to design any electronic chip or any other electronic devices, physicists and engineers are not considering this material. In the study, SI and their colleagues studied a semi-metal made up of 1 part of selenium, 4 part of ruthenium and 6 part of tin. Topological states have not been observed in Ce, Ru4, SN6, but it is similar to the other materials in which these have been observed. It is known to host the Kondo effect. But what is meant by Kondo effect? There are two types of electron. One which is attached to the atom, and second is conduction electron. So, the strong interaction between the magnetic moment of electron attached to the atom and the spin of conduction electron is called as Kondo effect. In experiment at TUN and NIST, a neutron research center has used magnetic susceptibility, specific heat and inelastic neutron scattering measurement to obtain quantum states of Ce, Ru4, SN6 in very cold temperature, and this test reveals the material is quantum critical in its native states without the use of external fine tuning. Now let's talk about spin Seebeck device. A thermoelectric conversion offers a carbon-free power generation technology from geothermal, waste body or solar heat, and gives a promise to the next generation of power generation technology. At the core of thermoelectric conversion, there lies a solid-state thermoelectric device which enables a power generation or a energy conversion without emission of noise, vibration or pollutants, and displaying the improved efficiency of conversion technology using spin Seebeck device. Conventional thermoelectric devices rely on the charge of Seebeck effect, and also called as a thermoelectric effect, wherein a current charge is produced parallel to the applied temperature gradient, and the longitudinal geometry complicates the structure and limits the manufacturing of thermoelectric devices. In this study, they have explained and presented the principle behind fabricating the next generation thermoelectric devices with much simpler structures than old conventional ones using spin Seebeck effect. And this method has dramatically improved the efficiency using heat treatment technique. Now let's talk about Milky Way. The detailed cross-section of a galaxy broadly similar to the Milky Way reveals that the galaxy has evolved gradually instead of being the result of violent mashup. This finding has thrown our origin story into the doubt. The galaxy UGC 10738 has turned out to have a distinct, thick and thin disk much similar to the Milky Way, reveals that this is the contrary to the existing story. The researcher says that the galaxy UGC 10738 has a thick disk consisting of the ancient stars identified by the low ratio of iron to hydrogen to helium, and the thin disks are more recent and contain more metal. Sun is a thin disk and it comprises of the 1.5% element heavier than the helium, and the thick disks are 3 to 10 times less than that of. Astro 3D director Professor Lisa Quelly has said that this study reveals that how Milky Way fits into the bigger puzzle of how spiral galaxies have formed across 30 billion years of cosmic time. So, this is it for today. See you in the next video. Till then, take care and goodbye.